Hello all. Today we discuss about 8251 programmable communication interface. So this is basically used for the serial communication, also known as TXRX communication. And 8251 is a programmable chip designed for synchronous and asynchronous serial data communication. And this is 20-pin dual inline package, and this is compatible with 8085 or 8251 peak microcontroller. Anyone can be used for the, although in a microcontroller there is a inbuilt serial data transfer also available, but for a microprocessor 8086 8085 are basically interface with this peripheral to communicate via TXRX or serial interface lines, either synchronous or in asynchronous mode. Okay, so first of all, in the left hand side, this is the pin configuration of 8251. This is first D2, D3, then D1, D0, and D4, D5, D6. So these 4 pins here, this is 2 pin and this is 2 pin. So therefore 8 pins. These 8 pins are basically known as 8-bit data bus. Okay, this RxD line is for received purpose. This TXD line is basically used for transmit purpose. Okay, to transmit the data. And the next one is, this is a clock, this is a reset. And next one, this is a ground pin. This is RDY means receive ready. This is transmit ready. This is for synchronous detection or break detect. This BD means break detect. This is clear to send. And what is RTS means request to send. Then CTS, then TXC is transmit empty. This TXC means, where is the TXC? Sorry, the TXC here. Okay, this TXC or also known as this, just a minute. Okay, this TXMT is known as transmit empty, also known as TXC. Okay, then we use here 1 bit, this C/D bar is known as control or data is to be written or read. This is for read bar, read facility, and for this is write for write facilities. This is a chip select pin to select the 8251. Okay, and then reset pin is used to reset this 8251. This is the reset pin. Okay, and next one is TXC. TXC is found here. This is transmitter clock. TXD is for transmitter data. We already talked about that. Where is the TXD? This is the TXD. Okay, and next RxD, we talk about that for receive the data for any peripheral device. RX ready. Where is RX ready? RX ready found here. This is RX ready for receiver ready, and TX ready for transmitter ready. Transmitter ready, we already talk about that. And DSR is a very important. This is for data set ready, and DTR for data terminal ready. Okay, this is also used for the in a next video will be discussed about thoroughly. RTS is already discussed about that. TXC is a transmitter and VC is a 5+5 volt, and ground pin is here, the ground pin. Okay, so now in a 8251 there are read and write control logic and the registers also used. And one thing should be remembered, there are read write logic, 6 input signals control logic, and 3 buffer register, data register, control register, and status register. Student, please note down, the input signal to be control logic are as follows. For the input signals, there are classification of lots of signals are available in the 8251. So before going any applications, discuss any application, first of all we just separate the different types of signal. Otherwise there is a problem in a programming. So this is the input signals. What are the input signals? The first input signal is a chip select, then control and control/data. So this chip select pin is used for When the signal goes low, then the 8251 is selected by the MPU or 8085 for communication purposes. C and D bar control and data means when this signal is high, the control register or the status register is addressed, and when this is low, the data buffer is addressed. The control register and the status register are differentiated by write and read bar signals. Okay, if we read the status, then read bar goes low, and if we write any data in the control register, then write bar should be low respectively. Write bar means this is the write facilities. Next signal name as write bar for write operation. This is read bar for read operation. This control are decision taken from the control unit of the 8285. This is the reset pin to reset the whole chip. This is clock signal to running this clock input, usually connected to the system clock. And this clock does not control either any transmission or reception rate. This clock is necessary for the communication with the microprocessor. It's clearly noted that. And next one is the control register. The control register is a 16-bit register for a control word, consists two independent bytes. First byte is called mode instruction and the second byte is called the command instruction. Okay, please note down, control register is a 16-bit byte. So control register is basically 16-bit byte. The first 8-bit are also known as mode instruction mode, and second one is known as command instruction. Okay, next one is status register. This is an input register to check the ready of the status of the peripheral, and this register is addressed as an input port when C and D bar pin is high. Okay, it has the same port address as a control register. Now data buffer is used for the to send any data, or bidirectional register can be addressed as an input port and output port when the C/D bar pin goes to low. Okay, now discuss about the transmitter section. In the transmitter section, the pins are TXD, that means TXD transmit data, then TXC transmitter clock, this is active low, must be active low. This is TX ready, data is ready or not, and TXC is a transmitter empty. So first of all, this TXD pin is used for serial bits are transmitted on this line, and TXC is this is input signal, controls the rate at which the bit are transmitted by the USART. What is the meaning of USART? USART means universal synchronous receiver transmitter. Okay, the clock frequency can be 1 or 16 or 64 times of the baud rate. Then TX ready means this is an output signal. Okay, and when it is high, this indicates the buffer register is empty. What is a buffer? Where we transmit data will be stored. And so when this is high, this transmitter TX ready is high, then transmit buffer register is empty and the user is ready to accept a byte. It can be used either to interrupt or MPU or to indicate the status. And next, transmitter empty is output, also called output logic, and logic 1 on this line indicate that the output register is empty, and this signal is reset when the byte is transferred from the buffer to the output register. Okay, so in the next video we will be discuss about thoroughly. And in the receiver section, what is the receiver section? The pin, different lots of pins are available. So first pin is known as RxD. This pin is used to receive data serially on this line and convert into the parallel byte in the receive input register. RxC bar is basically receiver clock. This clock signals that controls the rate at which the bit is received by the user. In the asynchronous mode, the clock can be set either 1 or 16 or 64 times of the baud rate. And Rx ready is the pin which is store the status of the receive ready. If this pin is an output signal, and if this goes to high, when the user has a character in the buffer register and is ready to transfer it to the microprocessor unit. This line can be used either to indicate the status or to interrupt the microprocessor or 8085. Okay, so in the next video we'll be discuss about thoroughly the initialization process of 8251 and what are the control register and what is the internal architecture of the TXD and what is the control logic and registers, what is the internal diagram of transmitter receiver and the programming of this 8251. So 8251 is basically, so this is the internal block of 8251. Basically here one block is a data bus buffer, next block is a to read and write control logic, this is a modem control to flow the data control, this is a receive buffer, this is a receive control logic. Here we attach 3 signals as we discuss about that, and here one is output this pin is also used here. In the later video will be discussed about thoroughly. This is known as the synchronous detect or break detect pin, also connected. Break detect also connect here, and this is for the receive purposes buffer. Here we store the one 8-bit register where you store the receive character. This is the transmitter logic block which control this transmit buffer. Either character is transmitted or not. Depending on this clock, we can set the baud rate different by this TXC pin, transmit empty, or by transmit ready pin we can decide it the data can be stored, data can be transmitted or not. So various lots of signaling pins are there, and they are depending on their status. The programming is dependent. Okay, so in this video we just talk about what is 8251 and what are the use of 8251 and what we need the requirement of 8251. So this is very important. Okay, and this is a source from the Intel Corporation. First, it is published by the Intel. Okay.